Good evening, professors, classmates, and dear guests. On behalf of Group 4, I'd like to extend a very warm welcome and thank you all for being here today. My name is Shafi, and I had the privilege of leading this project, and I am joined by my teammates like Ajas, Hana, and Afri. We are incredibly proud to present this low stock alert cloud application. Over the next few minutes, we will take you to the complete journey of this project from its core goals and technical architecture through the significant challenges we overcame and finishing with a live demonstration of a fully deployed application. To get us started with the vision and goals of our project, I will now hand over it to Ajas.
Thank you, Shafi. Go through the second slide. Yeah, thank you. Here, what was our main objective? Simply put, we aim to build a practical full-stack web application that solves a real-world problem, efficiently managing product inventory. To accomplish this, we built for our key features. The first one, the inventory dashboard that gives you an instant at a glance view of our business. The second one, a robust product management, allowing you to easily add, view, and edit items. Third one is automated low stock scanning. This is a smart backend process that regularly checks for the products needing to be recorded. And finally, email alert system. This system ensures you never miss a critical recorded by sending an automatic email notification when stock is low. Uh, now, let's look at the cloud architecture we use to build this. So if we go through the next slide. Yeah. Here, we design our application using a modern and decoupled serverless architecture. This is mean each part of the system is independent, which make it highly scalable and very cost effective. Our front end, the user interface you see, is the React application hosted on Azure Blob Storage as a static website. The backend, which is the brain of our operation, is a Node.js API running on a serverless Azure function app. For our database, we use Azure Cosmos DB in serverless mode, which was a key decision to keep our cost down. And for the sending our those crucial notification, we integrated the sending grid API as our email services. Next, I will break down the backend components in more detail for the next slide. Here our entire backend logic is powered by three separate Azure functions. We choose this serverless approach because the functions only run when needed, which is incredibly efficient. The first one is get products, which is an HTTP endpoint. The dashboard calls this is function not get the list of all products. The second one is upsert product, also an HTTP endpoint. This is one handles both creating a new product and updating existing one. And the most interesting function is the scan inventory for low stock. This isn't triggered by a user but by a timer. We said it run automatically even, every 2 minutes to constantly monitor inventory levels. The entire backend was deployed directly from VS Code. Now talk about the database, that is the function of connect to. I will hand over the presentation to Anna.
Thank you, Ajas. Now I will discuss the database used in our project. For the database, we choose the Azure Cosmos DB. It's a powerful NoSQL database that works perfectly with our serverless architecture. A critical decision here was using the serverless capacity mode. This is the ideal for our projects like ours because it includes a generous free tier and we only pay for the exact operation we use. Within our database, which we call the shop inventory, we created two containers. The product container, which holds our main inventory list, and the low report container, which keeps our timestamp history of every low stock events. Now that you understand our data layer, let's move on to the user-facing part of our application. Okay, here we're going to discuss the front-end hosting. The entire user interface is a modern single-page application built with React. An interesting part of our journey was a deployment method. While we initially considered Azure Static Web App, we successfully pivoted to using static website hosting within an Azure storage account. This proved to be fast, simple, and very low-cost way to host our application. A key concept here is the npm run build command package our entire application into simple build folder. The content of this folder must be uploaded to a special container on Azure called $web. Getting this upload process right was actually one of the most important challenges. Okay, let's move to the next slide. Our first major deployment challenge was a 404 not found error on our live website. The problem was that the server couldn't find the index.html file it needed to start the application. After investigating in the Azure portal, we found the cause. Our upload has created a build folder inside the $web container, creating an incorrect file path. The solution was clear. We deleted the incorrect upload and then used the VS Code extension to upload all the files and the folders from inside our local build folder directly to the root of our $web. This solved the problem immediately. That was our first hurdle. Now I will pass it to the Afrin to discuss the final connection challenges.
Thank you, Hannah. Let's move the next slide. In here, we can see the permissions and the final API connection. Even after the files were in the right place, the application still couldn't load data. This was a two-part problem. First one is a partial permission issue. We couldn't even see the files we uploaded in the Azure portal at first. We solved this by switching the authentication method in the storage browser from Entra ID and access key. This confirmed our files were indeed there. Second, we had a beacon API error. The browser console showed a 404 not found error when trying to fetch data. The case was incorrect beacon URL in our front-end code at the time it was built. The solution was a careful four-step process. We got the correct URL from our Azure Foundation, updated our environment files, rebuilt the React app, and finally we re-uploaded the new corrected files. This successfully connected our front-end to the backend. Now let's move the next slide. In here, we're going to see the critical configuration cross-origin resource sharing. The final piece of the connection puzzle is web security feature called CORS. The best way to think about CORS is like a security guard for your API. By default, the guard stops the website at one address from making requests to an API at the different addresses. To fix this, we had to explicitly configure to force settings on our backend function app. They simply added our frontend's URL to the allowed origins list. This is like giving the security guard a photo and saying this website is a friend. You can let it request through. This was the final critical step to allow our frontend and backend to communicate freely. Let's move the next slide. In here, finally, we can see the final outcome and conclusion. So after designing our architecture and navigating those key development challenges, we are very proud of the final outcome. The project is a complete success. Our live front-end and publicity accessible and fully functional on Azure. Our live backend is running in the cloud, ready to serve data and scan inventory. Our live database is connected and responding instantly. And our live alert system is configured to send real-time emails notifications Now to see it all working together, I'll hand it back to our team leader, Shafi, for the live demonstration.
Thank you, Afrin, for the most exciting part. I'm going to show you the application working live, right? So now I'm gonna show you how the application is working. I will see the final output of our application, right? So wait, let me share the screen first. As you can see, this is the live dashboard, right? So this is our live dashboard, which is running on Azure, right? It's immediately fetching the current products list from our Cosmos database. So you can see our Cosmos database here. So when you go to the Data Explorer, you can see our Cosmos database. So with this database only, the items are stored. So here we have the products. So we have 12 products, right? And with the real time, it will check what are the low stock items are available. So in our case, we have 12 products and we have 6 out of stock contents. So in the meantime, we can check for the AI assistant, right? So it will check what are the things are out of stock, and it will give you a message like you just have to you have to move this. The current quantity of our flour is 25, so we have to reach 40. So it will give a message like it's an automated one. So we have used Gemini API for this AI tool, and in the meantime you can add a new product. So let me add a new product 013, and I'm gonna add like product name is like mutton. Quantity I'll be like I'm having 15 kilos, but I should maintain 50 kilos per day. So I'm gonna add this. So now I have added the mutton, so it's right, it's a low stock. So in the meantime we'll get a message, right? So in the meantime we'll get a message here, right? So these are the message we'll get in the real time. So it will automated for each 2 minutes, right? It will be automated for each and every 2 minutes. So you can add a new product, and in the meantime if you automatedly add the product value, you can update like current quantity. I'll be like I'm updating with 10, and for this what do you call this, for this chicken it's like 20. So you can update as well, right? So this is a nice interface you can have. So in the meantime, if you go to the settings, you can change your name, you can add a profile picture for your dashboard. So this is about the front end, right? So when you go to the backend, database, so these are the database you can see. Shop inventory is our database, right? And we have 2 containers here, product container and low stock reports container. So you can see the items here, and if the low stock items found, it will automatically stored in our low stock reports container. So this is how the backend and front end is getting connected. And in the meantime, right? So I remember Ajas Hannah told about the bill file. So in the front end we have a bill file, right? So in the bill file, with the bill file only we have uploaded our front end, right? So we have uploaded our front end using our storage account. So in the storage, you can go to the monitoring this setting, right? So inside, so below the setting you will be like having static website option. So it's in the data management. So when you once go here, so you can find the primary endpoint, right? So this index.html is made us several times made us failure. So here we have the primary endpoint, and with this endpoint only you can move up to this dashboard. So with this storage dashboard, we have deployed our front end. So now to work the backend, the final step was our course, right? So we have added this, right? This front end to connect with the backend. So this is what made us our project live. So until that we had several failures, and we overcome with these with the support of the most of the AI tools. And we have added the environment variables, like so we have manually added this one. Here we have added Cosmos DB connections, and what are the database we are having, and what are the containers. So we have the shop inventory database, and the container is product and low stock reports. And what is our SendGrid API? SendGrid API is an API that we use to send the message, right? So here in the real time, so you will receive a message. So what are the things are, out of stock. So to generate this, we use SendGrid, API. So that's what we have used here. And I have used, this email to send and receive the, what do you call this, stock details. And what about the, what do you call this, React project goes, we have, when you click this one, it will automatically navigate to the products details, right? So it will tell like what are the products you need to add, how much you have to add, so how much you need to reorder. So these kind of things a shop owner can see, right, while he is in this dashboard. So we completely use this VS Code, to upload our backend and frontend. So here, so we have this low stock alert email folder. So here we have, in the backend, we had three functions: get product function, scan inventory for low stock, and upsell products. So with these functions only, our backend is, working. And in the local environment, we use Cosmos
Please share the
DB
screen.
emulator. Wait, let me share.
Yeah, share the screen.
Thank you for reminding me, right? So I think now it's changed, right? So this is our, this is our project code. We use Visual Studio Code, right? So here we have in the backend, we use like get products function, scan inventory for low stock, and upsell product, right? So with this only, our project is working very well, right? So to upload this, we had Azurite. So this is an extension that you can get from these Visual Studio Code. So in the Azurite, we have several options, right? So you can sign in here and you can use all the features that are available in the cloud. So with these options only, I just, deployed my whole project. So here you can see an Azure tab here, right? So if you deployed a project at a real time, you can see if you have deployed it or not. So with this only, I have uploaded the projects. And further, so in the local settings, so here you can see this. So I have used like for the local setup, I have used like local Cosmos DB emulator, right? So with that emulator, I have deployed. And for the front end, we normally use React, right? So, and in the environment file also, we have utilized our backend, right? So backend with this React application, so then only it will communicate. So that's why we use this React application based URI. And to connect this with the cloud, we have uploaded this code in the course environment, right? So I already told you like this one, right here, right? So here we have added this one. So this is like our complete project, deployment. So how we have deployed our whole project and how this system is working, right? So once I just want to tell you, like, this is a system, right? To use for the restaurants or the hotels or whatever the inventory is there. So whenever we use an inventory, we can use this system. So it's like you can add the whole system, whole products, right? Like if you take a restaurant-based industry, you can add all the products which are needed for the industry. And you can add the values, right? Like this current quantity means what is the current quantity it's having. Reorder level means for per day how much we need. So if the current quantity is less than the reorder level quantity, it will tell that the item is low stock. So if it detected, you can automatically get the low stock alert. So these are the products we are getting low stock. And in the meantime, if the owner, purchase some goods and all, in the real time he can edit. So if we think, right, so he has purchased all purpose flour, so he can edit and he can save. So the low stock item will be 5, right? It will be reduced. So in the meantime, in the real time, it's working fine. So that's it about our whole project. 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 So that's If you have any doubts, audience, you can ask. Right. This is a question and answer Q&A session. So if anyone have any doubts, you can ask.
I have one question for you guys.
Yeah.
Can you tell me how much it cost for running your application in Azure Portal Lively?
Yeah. Yeah. For this question, I would like to invite my teammate Afrin to answer.
Yeah. Right now it costs us effectively $0. This is the biggest benefit of the serverless architecture we choose. The free tiers offer Azure Functions and Azure Cosmos DB serverless are so generous that our applications usage falls completely within those free limits. It's an incredibly cost-effective way to host a powerful application and would only start to incur cost if we had thousands of active users.
Yeah, exactly. Simply, we can say that it's a low cost, right? So we don't pay anything, right? It's a low cost and it's a serverless model. So that's why we choose this Cosmos DB and serverless model. So I hope you get the answer for your question, right? Hafas?
Yeah, sure.
Okay,
Sure,
thank
sure.
you. So if anyone have any doubts, you can ask.
I have one question.
Yeah.
Why did you choose to use serverless Azure functions for the backend instead of the more traditional web servers?
Yeah, it's a good question. We choose Azure, it's because of the two main reasons. Like the first one is because of the cost, and second one is because of the scalability, right? With the serverless model, we only pay for the exact moment, right? So if the code is running only, we have to pay. So it's a cost friendly. And if the function run less than a second per request, the cost is practically zero. So you don't need to pay for that. And for the second one, Azure function would automatically scale to handle the load without us, having to manage anybody call this servers. So because of these two reasons, we choose these Azure functions, scalability and cost management. I hope you get the answer, right?
Yeah, I got it.
Thank you. So I think end of this session, I think everyone got the clear idea about this project. On behalf of our group, I would like to say a big thank to everyone who involved with this project and all. So thank you everyone.
Thank you, Shafi.
Thank you.